मॅम माईक म्यूट आहे का तुमचं?
Okay, sorry. Okay, sorry. Now audible?
Yes, ma'am. Yes, ma'am.
Sorry. Okay. I will explain once again. So in last lecture, we have seen the continuity equation of current. Okay, so continuity equation of current means here we are finding the current which is crossing that closed surface, right? So we have seen this equation. So when we are considering that the current is actually crossing that closed surface, that time whatever be the direction of current, according to that our equation will change. So that current is nothing but the rate of change, rate of flow of charges, which is dqi upon dt. Okay, so if that current is going in outward direction and if that is in inward direction, so what will be the direction of that current? Okay, uh, means what is the value of that current is obtained here. So when it is in outward direction, so that rate is in negative. That is, this is showing the decrease in the charges or decrease in the current in that volume we are considering. Okay, so then when you are considering that that current is in inward direction, okay, that time this is minus I, it is equal to plus dqi upon dt here. Okay, then we have to obtain the point form of this continuity equation. So we can write this equation as closed surface integral of j bar dot ds bar is equal to the volume integral of del dot j bar into dv. Okay, so this is in the integral form. Then it is therefore this minus dqi upon dt is equal to the volume integral of this del dot j bar into dv. So can anyone tell me this is from what? This equation is taken from which law or which theorem? So this is the divergence theorem, right? Now the divergence theorem we have seen the integral form of Gauss law. Then we have seen the divergence theorem. What divergence theorem is saying? How this equation is coming? Actually, the Gauss law is q is equal to psi is equal to the closed surface integral of j bar dot ds bar, right? And what is the divergence theorem? So if you check the equation, divergence theorem is closed surface integral of d bar dot ds bar is equal to volume integral of this del dot d bar into dv, right? No? It is del dot d bar. So instead of this vector d bar, we are using here vector j bar. Okay, so just replace this and you can write this equation. That is the divergence theorem. So from this equation, uh, this closed surface integral of j bar dot ds bar is equal to minus dqi upon dt, right? It is equal to current I. You can see here the first equation when we are considering that current is going in outward direction. So this current I is equal to closed surface integral of j bar dot ds bar, which is equal to minus dqi upon dt. So we have to just replace this left hand side by this minus dqi upon dt. Okay, so this side, which is equal to right hand side same, that is volume integral of del dot j bar into dv. Okay, but qi is equal to, so if we write the equation for only charge, so this charge q can also be written as the volume integral of rho v into dv, right? No? And what is this rho v? Rho v is equal to del dot d bar. So we can also find the charge. Okay, we can also find the charge from this equation. We have seen these equations in second chapter. You can see that because when we have seen the Gauss law, that time I given you these equations. We can find the charge by using this equation also. That is volume integral of rho v into dv. Okay. So where this rho v is equal to volume charge density. Now we have to just put this in equation of this volume integral. So volume integral of this del dot j bar into dv is equal to so minus it is equal to minus dqi upon dt, right now. So it is equal to minus d upon dt of this qi. And what is this qi? What is this qi? This qi is equal to volume integral of rho v into dv, right now, right? So what we are doing, we have to find this volume integral of del dot j bar into dv, right? But we know that it is equal to minus dqi upon dt. So we are writing equation for this qi. This qi is equal to volume integral of rho v into dv, right? And this rho v is equal to volume charge density. So it is equal to, if I put only here the value of this qi, so it is equal to minus volume integral of, now here we are taking the partial derivative. Okay. So for a constant surface, derivative becomes the partial derivative. Okay. So here it is minus volume integral of dabba rho v upon dabba t into this dv. Okay. So this volume integral of del dot j bar into dv is equal to volume integral of minus dabba rho v upon dabba t into dv. Now, if the relation is true for any volume, okay, if this relation is true for any volume, it must be true even for incremental volume. Okay, means when we are considering any shape or any type of volume there, and for this, if this equation is true, then we can say that if there is some increase in the volume, then also it should be true. Okay, it should be true. So this as these two sides are the volume integrals, right? Now this is also volume integral, this is also volume integral. So if we remove this volume integral, okay, दोन्ही sides जर same असतील, volume integral असेल, or if to the left side it is surface integral and to the right side also it is surface integral, okay, then also you can remove that. Okay. So if we remove this volume integral, means del dot j bar into delta v, dv means delta v is equal to minus dabba rho v upon dabba t into delta v. So means we are considering a small increase in that volume, means which is denoted by delta v here. So again, if we remove this delta v and delta v, we are getting this del dot j bar is equal to minus dabba rho v upon dabba t. And this is the point form of the continuity equation for current. Okay. So remember this. So when they are asking you continuity equation of current, as I told you, it is asked many times in examination. So you have to write this equation. Okay. Now for a steady state currents, okay, means those which are having the constant values for steady state currents, which are not functions of time. Okay, so this dabba rho v upon dabba t becomes 0. So your del dot j bar is equal to 0 there. Okay, so this is for steady state current. So you can write these equations when in examination they are asking. Okay. Now, we'll see one more example is there. Okay, so all of you got these equations? Yes or no? समजलंय का सगळ्यांना? समजलंय का? And once you read this, you will understand. Okay. Yes. Okay, so write down here one example. We first find the total current in outward direction. Okay, we have to find the total current in outward direction from a cube. Okay, means here your volume is nothing but a cube. Okay, is a cube, and we have to find the total current in outward direction. In outward direction, this cube from a cube of 1 meter. Okay, 1 meter means each side length is equal to 1 meter. Okay, with one corner at the origin. Okay, with one corner at the origin and edges parallel to the coordinate axis. Okay, so you can see here such a diagram is drawn here. So one corner of this cube is nothing but the center, or is nothing but the origin, and all the edges of this cube are nothing but x, y, and z axis. Okay, so this x axis is making one edge, y axis is making one edge, and your z axis is making one edge. Okay, so and edges are parallel to the coordinate axis. Okay, so you can see here with all means one is here and others are parallel to all the axes. So you can consider any surface 2x square a bar x plus 2xy cube a bar y plus 2xy a bar z ampere per meter square. Okay, so here J bar is given and we have to find the total current. So which formula we have to use here? Can anyone tell me which formula we have to use here? Yes, we want to find current. Which formula should be used here? Yes. So what is formula to find current I? Yes, how to find current I? Anyone? Prajakta? Yes, anyone? How to find current I?
Closed surface integral into J bar ds.
Correct, correct. It is closed surface integral of J bar dot ds bar, because here current density is given, right? So we have to find this form. So the continuity equation of current is closed surface integral of J bar dot ds bar, right? Now, so if we use this equation, so J bar is given here, right? Na? J bar is given. So can you find this ds bar? What can be the ds bar? कारण काहीच दिलेलं नाहीये ना. Okay, so for finding ds bar, what is required? One plane should be constant, right? Na, म्हणजे x is equal to constant, y is equal to constant, z is equal to constant. Any one of the planes should be constant there. Okay, but it is not given, because here we have to find the current which is coming out from that volume, from that whole volume. Okay, so we cannot consider that for this particular constant, for that particular axis or that particular plane, just do not consider that from that particular plane the current is not coming outside, so we cannot consider likewise. Okay, so what we have to do, we have to consider the equation for total volume, right? Na, we cannot find the current passing through any surface here. Okay, म्हणजे समजा हे काय एक्स इज इक्वल टू कॉन्स्टंट प्लेन आहे, तर त्या सरफेस मधून काही थोडा करंट बाहेर येतोय. वाय इज इक्वल टू कॉन्स्टंट प्लेन असल्यानंतर त्याच्यामधून थोडा बाहेर येतोय. म्हणजे आपण तो पर्टिक्युलरली फाइंड करू शकत नाही. आणि जर केला तर काय करावं लागेल आपल्याला, सगळे सरफेस कन्सिडर करावे लागतील, राईट ना. मग किती सरफेस आहेत, 6 सरफेसेस आहेत. मग 6 सरफेसेस साठी तुम्ही फाइंड करणार का, नाही, राईट ना. म्हणजे टोटल करंट जर तुम्हाला फाइंड करायचं असेल आणि तुम्ही जर सरफेस इंटेग्रल यूज केलं तर काय करावं लागेल तुम्हाला, हे जे 6 सरफेस आहेत या व्हॉल्यूमचे किंवा या रेक्टँगलचे, तर ते 6 सरफेस कन्सिडर करावे लागतील, राईट. तर instead of that you are having this equation, right? So this current I is equal to closed surface integral of j bar dot ds bar, and it is equal to volume integral of del dot j bar into dv, right? Right. So this is nothing but your divergence theorem. So here you know this del dot j bar, this vector is given. So del dot j bar means if there is a dot product, it is nothing but divergence. Okay, so you can find this, and you can also write the equation for this dv. Okay, dv means the total volume, differential volume of this cube. Okay, so the total volume or differential volume is given by dv is equal to dx dy and dz, right na, right? dv is equal to dx dy and dz. Now just to put the given j bar here and take the dot product with del dot. Okay, so you can first find this del dot j bar, because you will get here which type of value you will get, a scalar quantity or vector quantity you will get when you are taking the divergence. Which quantity you are getting, scalar or vector? Yes, when
Scalar.
Scalar quantity, correct, because it is a dot product and del is a vector quantity, this j bar is a vector quantity, and when we take the dot product of any two vectors, then it is nothing but a scalar quantity. Okay, so first find this so that you will get a scalar quantity, and then you can integrate with respect to this dv. Okay, so we'll find first this del dot j bar. This del is equal to dabba upon dabba x into a bar x plus dabba upon dabba y into a bar y. I'm only saying these equations, and plus dabba upon dabba z into a bar z. And this j bar can be written as jx a bar x plus jy a bar y plus jz a bar z. So if you take the dot product of these two equations, so are you writing this? All of you solving this equation? Yes or no? समजते का काय झालंय? स्नेहल, स्नेहल, रोल नंबर 30.
Yes, ma'am.
समजते ना? ओके ओके ओके. मोहिनी, मोहिनी रोल नंबर 9. समजते का? Okay. So here for your understanding, you can write equation for this del bar, then write equation for j bar in terms of jx a bar x plus jy a bar y. Then if you take the dot product, all unit vectors will cancel and just multiply the magnitudes, then you are getting the scalar quantity. Okay, so when I take the dot product, that is del dot j bar is equal to dabba upon dabba x of jx plus dabba upon dabba y of jy plus dabba upon dabba z of jz, right? Now I want to find this jx, jy and jz. So how to find this jx? From which equation? From which equation this 2x square and 2xy cube, these are taken?
Current density.
Yes, from current density equation. It is already given here, current density equation, right? Na? This J bar is given. So this J bar is nothing but Jx a bar x plus Jy a bar y plus Jz a bar z. Okay, means Jx is equal to 2x square, Jy is equal to 2xy cube and Jz is equal to 2xy. Okay, so you have to compare these two equations, then you can write equation for this. Okay, so if we put here the values, then just differentiate dabba upon dabba x of 2x square is nothing but 4x, right? Plus dabba upon dabba y of 2xy cube will be 2x constant. Okay, for y cube it is 3y square. So 3 into 2, 6xy square, right? Plus dabba upon dabba z of this 2xy. There is no z quantity. Okay, no z quantity means this 2xy is equal to constant and its partial derivative is equal to 0. Okay, so this del dot j bar is equal to 4x plus 6xy square. Okay, now just to put this in equation of current, this current I is equal to volume integral of this del dot j bar into dv. Del dot j bar is equal to 4x plus 6xy square. Okay, into dv. And dv differential volume for the Cartesian coordinate system. Why we are using that cube? Cube is nothing but rectangle. Okay, that is nothing but a कार्टेशियन कोऑर्डिनेट सिस्टीम. ओके, म्हणजे कोणताही शेप दिला तरी तुम्हाला काय अप्लाय करायचं हे समजलं पाहिजे. म्हणजे त्यांनी क्यूब दिलाय आणि तुम्ही सिलेंड्रिकल सिस्टीम यूज करणार का? क्यूब दिल्यावर सिलेंड्रिकल सिस्टीम नाही. ओके, so likewise first check the given data and according to that you have to use the coordinate system. Okay, if they are saying that there is a what we can say, that there is a sphere or there is a cylinder, then the particular systems you have to use there. Okay, then just integrate with respect to x, y and z. So and here now the limits are from 0 to 1 because each side is of 1, right? Na 1 meter is given. You can see here outward direction from a cube of 1 meter. म्हणजे cube ची length किती आहे? तर 1 meter आहे in all directions. Okay, means in x direction, y direction and in z direction also length is equal to 1 meter. Length is equal to 1 meter is nothing but it is the distance from origin towards that particular axis. Okay, towards that particular axis. So limits are from 0 to 1 for all three axes. So it is integration from x is equal to 0 to 1, integration from y is equal to 0 to 1 and integration from z is equal to 0 to 1 of this 4x plus 6xy square into dx, dy and dz. So simply now integrate. Okay, so current I is equal to, now first integrate with respect to x. That time you are getting z is equal to 0 to 1 and y is equal to 0 to 1 of this. We are integrating with respect to x. So for 4x, it is 4 into x raised to 1 plus 1 means it is x square divided by 2. Okay, plus 6 y square will be constant, right? 6y square is constant and only x is variable. Therefore, it is 6y square x square Okay, 6y square x square divided by 2. Okay, and this dy and dz will remain same. So, and the limits will be from x is equal to 0 to x is equal to 1. Okay, therefore, it is equal to z is equal to 0 to 1, y is equal to 0 to 1 of this. Just to solve this, so it is 2x square plus 3x square y square into dy dz, into dy dz. Okay, so it is equal to, now integrate with respect to y. Okay, so integration from z is equal to 0 to 1 will remain as it is. Just integrate with respect to y. So it is 2y, right? It is 2y plus 3, y cube divided by 3 from 0 to 1. Okay, into, now only dz will be there. Okay, so here it is given. So if you solve this, it is equal to integration from z is equal to 0 to 1. 2 into 1 minus 0 means it is 2 plus 3 get cancelled. Again it is 1 cube. So what is 1 cube? 1 cube is again 1. Okay, minus 0 means 1. So the answer is 2 plus 1 into dz, that is 3 dz. Again integrate with respect to z, that is integration from z is equal to 0 to 1 into 3 dz. Now 3 is constant, integration of dz is z from 0 to 1, and it is equal to 3 into upper limit is 1 minus lower limit 0. So your current I is equal to 3 ampere. Okay, समजलंय का? Yes or no? समजलंय का? Yes or no? So I hope everybody got this. Okay. So if you have finished, can we discuss the next point? Syllabus is very vast. This chapter will still take minimum 4 lectures, I think. Minimum 4 to 5 lectures it will take. Okay. Okay. So we'll see the next point. That is the Poisson's and Laplace's equation. This is also important point from this chapter. Okay. These equations are also asked many times in examination for 4 marks. Remember, or sometimes they can ask for 6 marks. Poisson's and Laplace's equation. Okay. So everybody concentrate. You just see here how these equations are coming. Then if you read only once, you will understand that. Okay, but first understand how the equations are coming. Okay, and in notes also everything is written very clearly. Okay, so no problem if you understand the previous concepts. Okay, so we know the Gauss law. So, and the point form of Gauss law. So what is the point form? Rho v is equal to del dot d bar, right? Rho v is equal to del dot d bar. So here we have to use this point form of the Gauss law. So from this equation we can find the Poisson's and Laplace's equation. So where this d bar is the flux density, rho v is the volume charge density. Okay, rho v is volume charge density. Now this d bar, okay, this d bar is also equal to epsilon into e bar. Okay, all of you know the relation between the magnetic electric flux density and field intensity. That is d bar is equal to epsilon into E bar. Also, we can write the equation for E bar again. So if we put this equation in the equation number 1, okay, so it is dot dot, and this d bar is equal to epsilon E bar is equal to rho v, is equal to rho v. Now from the gradient relationship, so as I told you, we have seen the relation for this E bar. We have seen the relation between the potential and field intensity or electric field. That is E bar is equal to minus del into V, right? Minus del into V. So again we have to put instead of this E bar as minus del into V. Okay, so it is del dot epsilon into E bar is equal to minus del into V is equal to rho V. So if we take this epsilon outside as a constant, so this minus epsilon is into bracket del dot it is del into V, it is del into V. And one more thing is that you just so can anyone tell me, I'm writing here del bar and sometimes I'm writing here only del. Both are same or different? Both are same or different?
Different.
Different. Why it is? Yes. Suraj, Kiran. Yes, anyone? Chandana. Both are different or same? Okay, just remember this is a del operator and del operator is always a vector quantity. If you don't give bar, it is showing you the vector quantity only. And if you are giving bar, then also it is a vector quantity. So no difference between the del and del bar. Remember only the del operator is always a vector quantity. So if you don't remember, you can put the bar. Okay, you can put the bar, but it is not compulsory to put the bar. Okay, means नाही दिला तरी पण चालेल. Okay, so here from me only it is missing, but it doesn't matter because it is a vector quantity. Okay, so here if we take this minus epsilon outside, so we are getting this del bar dot this del into V, or it is del bar into V, or I'll always say only del here, del into V, and it is equal to rho V. It is equal to rho V. Okay, so I'll take this epsilon to the right side in the denominator. So I'm getting this left hand side as del dot del into V is equal to right hand side minus, okay, this sign is coming to the right side, so it is minus rho V divided by epsilon. Okay, so this is del dot del. Okay, it is nothing but a del square, so it is given, it is a del squared operation. So this del dot del is nothing but del square, because this dot product is nothing but a multiplication, right? No, dot product is nothing but a multiplication. So this del dot del is equal to del square into V, and it is equal to minus rho V divided by epsilon. Okay, it is equal to minus rho V upon epsilon, and this is called the Poisson's equation. This is called the Poisson's equation. Okay. Now the Laplace's equation. So if in a certain region volume charge density is rho v. Okay, म्हणजे when we are considering a particular region and for which the volume charge density rho v is equal to 0, which is true for dielectric medium. Okay, dielectric medium, then the Poisson's equation becomes this del square v is equal to 0. Okay, means for dielectric materials or when your volume charge density is equal to 0, that is rho v is equal to 0, then your Poisson's equation will become del square v is equal to, if this rho v is equal to 0, this del square v is equal to 0, and this is for a charge free region. Okay, remember the Poisson's equation is del square v is equal to minus rho v upon epsilon, but for the Laplace's equation, this right hand side is equal to 0, and remember they are asking sometimes the examples also. Okay, so this is a special case of Poisson's equation and is called the Laplace's equation. So the del square operation is called the Laplacian of v. Okay. Any doubt up to this point? समजलंय का?
हॅलो,
हा, येस येस.
ते मायनस रोव्ही कसं येते तिथं, म्हणजे मायनस काय इंडिकेट केलंय?
मायनस का? हा, एक मिनिट, मी जस्ट ते लेफ्ट हँड साइडचं राईट हँड साइडला घेतली.
हा.
हे बघ. आपलं काय इक्वेशन? This is what? This is E bar, na? We have seen the derivation for E bar. This E bar is equal to minus del into V, right? We have seen potential gradient, right? Na?
Yes.
That time we have seen this equation E bar is equal to minus del into V. So if I put this equation here, del dot epsilon into E bar, instead of E bar, just put here minus del into V. Okay, so the equation becomes del dot epsilon into minus del into V, that is E bar, is equal to rho V. And here this minus sign is taken outside, and this epsilon is a constant, right? So this minus epsilon constant is taken outside here, outside. So this minus epsilon into bracket, what is remaining? Del into del dot into del into V, right? Na? Minus epsilon outside घेतलं. So the remaining quantity is del dot del into V. So this del dot del, okay, so it is a dot product, means if we take dot product, it is nothing but del square. Okay, del square. So this minus epsilon is taken to the right side here. Okay, divided by minus epsilon, means the sign is minus, right? Na? So it is minus rho v divided by epsilon. And so this is del square into v is equal to minus rho v divided by epsilon. Okay, clear now? Clear now, Preeti?
Yes, ma'am.
Okay, now we'll see the example. Okay, so before that there is a del square operation. Okay, as they are asking you examples, so you have to see first this point. Okay, we'll see del square operation in different coordinate system. Del square means what we are taking here? Del dot del, right? Right. So we have to write this for all coordinate systems here. Del dot del. Okay, so in Cartesian, del into V. Okay, del into V is what? It is a gradient, right? Na? Del into V is gradient. So it is equal to जेव्हा ए सिंपल व्ही किंवा काहीतरी असेल, एखादी स्केलर क्वांटिटी असेल, तर त्यावेळी काय करणार आहे? इट इज डेल इंटू व्ही अँड इट इज गिव्हिंग यू ग्रेडियंट. ओके, when you are taking the dot product, that is giving you dot product of that vector quantity, it is giving you divergence. And when it is the cross product of the vectors, then it is giving you the curl. Okay, so remember this. So it is this del square v is nothing but del dot del into v. So this del into v in Cartesian coordinate system is del is again a vector quantity and just multiply here by v. So it is dabba v upon dabba x into a bar x plus dabba v upon dabba y into a bar y plus dabba v upon dabba z into a bar z. Okay. So this is del dot del into v. Again, you have to multiply by this del. Okay, del. So, and it is a dot product. It is a dot product. So if you multiply by del, dot. So del is dabba upon dabba x into a bar x plus dabba upon dabba y into a bar y plus dabba upon dabba z into a bar z. Right? That is only del. And take its dot product with this del into v. So if you take the dot product, just tell me it will be a scalar quantity or vector quantity. काय असेल? Scalar quantity का vector quantity असेल?
Scalar.
Of course, it will be a scalar quantity because it is a dot product. Okay, so just to take the dot product, all the vectors will get cancelled here, unit vectors, and it is the double derivative. Okay, it is a double derivative. So I hope you understood this equation, and it is nothing but del square v. So if we multiply in the bracket, so it is given dabba 2 by dabba x square plus dab into v, then dabba 2 by dabba y square into v, and dabba 2 by dabba z square into v. And it is equal to 0. So this is the Laplace's equation. This is the Laplace's equation. But when it is Poisson's equation, then it is equal to minus rho v divided by epsilon. Okay, minus rho v upon epsilon. But if it is Laplace's equation, then it is equal to 0. This del square v is equal to 0. Okay. Then similarly, you can find for the cylindrical coordinate systems. Okay. So here the directly equations are given. The same process is there. First find this del into v, then take the dot product with again del, then you will get the del square v. And similarly for spherical systems also the equation is given here. Okay. So you have to remember these equations. Del square operator in different coordinate systems. Okay. So are you writing these equations? So still boundary conditions are remaining. Then dielectric materials, polarization point is there. I think again capacitance is there. So many points are remaining from this chapter also. And we'll see one example also on this Poisson's and Laplace's equations. Means if they are asking you example, and for that purpose also you should know this formula. Okay. Just see how many formulae are there. For gradient, divergence, curl, different formulae in different coordinate systems. Plus now for this del square operator. Okay. And in between that, there are so many. Okay, completed. Can we see the example? Okay, note the equations. Any doubt? Okay, so we'll see now with the example. So verify that the potential field given below satisfies the Laplace's equation. Okay, so for this purpose, you should know the Laplace's equation, that is del square V is equal to 0, right? Now, del square V is equal to 0. But which coordinate system is used? For which coordinate system we have to apply this formula? So here that potential is given, right? V is equal to 2x square minus 3y square and plus z square, right? X, y and z coordinates are there, means it is a Cartesian coordinate system. If they are giving you somewhat r, phi and z, okay, means some angle they are giving you, etc., then you can say that it is a cylindrical coordinate system. If they are giving you two angles, then it is a spherical coordinate system. Okay, so given field is in Cartesian system here. Okay, given field is in Cartesian system. That's why we have to use del square V is equal to dabba 2V. Sorry, it is dabba 2V upon dabba x square plus dabba 2V upon dabba y square plus dabba 2V upon dabba z square. So it is equal to dabba 2 upon dabba x square of this V. Okay, so every time you have to put here V. Okay, for dabba 2 upon dabba. So sorry, here y square. Just do the corrections here. Here it is dabba 2 upon dabba y square of this V and dabba 2 upon dabba z square of this V. Okay, so just differentiate. So it is double derivative. So we have to differentiate first. So if we differentiate with respect to x, then it is plus 4x. Okay, plus 4x minus, here no x quantity, therefore it is 0, plus again no x quantity, that is only z term is there, therefore it is 0. So the derivative is equal to only 4x. But here it is double derivative. We are taking the single only. So it is dabba upon dabba x of this 4x. Then dabba upon dabba y of, first differentiate this with respect to the y. So here 2x square, no y term, so it is 0, minus 3y square, means dabba upon dabba y of this 3y square is 6y. Okay, and the sign is minus here. Okay, so it is given dabba upon dabba y of minus 6y, and for this term again 0, then plus dabba upon dabba z of these two terms become 0 and it is only 2z. Okay, so again you have to differentiate this because this is only a single derivative is taken here. And if you differentiate once again, so it is dabba upon dabba x of 4x is 4, dabba upon dabba y of minus 6y is minus 6, and dabba upon dabba z of 2z is z only. Okay, so if you check this, it is 4 minus 6 plus 2. it is equal to 0. So it is satisfying the Laplace equation, that is del square V is equal to 0. So if your answer is not equal to 0, if it is not equal to 0 and if they are asking you the Laplace equation, then your answer is wrong. Remember that. Okay. So समजलंय का सगळ्यांना? Yes or no?
Yes.
Okay. Then we'll see the next point. Okay, now dielectric material started. Okay, no problem. Actually, this is a concept first, means what are the dielectric materials we have to study first there. Means the capacitor, in that capacitor is having the two plates, right? Na? Capacitor is having two plates, right? So in between the two plates, there is a dielectric material. Okay, so that material is the dielectric material. Means I think in last lecture only I told you that that they are having same means positive and means it is a neutral point, you can say. Means no free electrons are there, means when you are considering the conductor, that time there are free electrons, right? That's why it became a conductor. But if there are no free electrons, means the point is neutral. But what actually happens when you are giving supply, then they are building some what their conducting capacity. Okay, so but very small current is flowing through that, right? So these are the dielectric materials. So we will see that in next lecture. So any doubt? If you are having any doubt, you can ask me. Dielectric materials, then polarization point is there. Okay, so any doubt? Anyone want to ask? Yes or no? काही विचारायचंय का? प्रशांत,
Yes, ma'am.
any doubt? Anything else? समजतंय का शिकवलेलं? समजतंय का? I
Yes,
think
ma'am.
समजत नाहीये. Only a single
Ma'am,
reply.
कसं नाही?
Okay. What about others?
समजतं मॅम.
का ओव्हर होत नाहीये ना? Okay, but keep practicing. Regular practice is necessary for EME. Otherwise, if you go to the last stage, means at the examination, and if you open the notes or any book, so it will hang you. Okay, that's why attend all lectures. If you at least you hear that at least once, then you'll understand at least, means whatever points are there, how to take these points. So just if you don't have time, actually it is compulsory, but sometimes if you want to miss the lecture, that time at least hear something so that you'll understand the concepts. Okay, and just revise all formulae. And as I told you, so all of you written this formulae in one another separate pages. लिहिलेत का सगळ्यांनी सेपरेट फॉर्म्युले? लिहिलेत का? येस और नो? वर्षा,
येस मॅम,
प्रीती?
चॅप्टरचे फक्त लिहिलेत.
ओके, सगळ्या चॅप्टर्सचे असे फॉर्म्युले काढायचे सगळे. ओके, आणि सगळे लिहून काढा आणि सगळे फॉर्म्युले पाठ करा. कारण आता बघताय तुम्ही, जसे नेक्स्ट चॅप्टरला जाल तस तसे फॉर्म्युले तुमचे वाढत जात आहेत. ओके, अजून तसंच 4th चॅप्टर पण आहे, तो पण वास्ट आहे. ओके, हा थोडा छोटा आहे, पण ह्याच्यापेक्षा 4th आहे, 5th, 6th we can cover, okay, within time only. These are easy to understand, but up to the 4th chapter will require lectures. Okay, so everybody, you revise whatever things or whatever points are covered in lecture. Okay, so for today we'll end here, and if you have any doubt from this you can ask me. Okay, so thank you all and have a nice day. Thank you.